In the spring of 1905, Albert Einstein took the train back home from work and noticed that if the train receded at the speed of light, the clock's hands on the tower would completely freeze yet tick at a normal pace. The question now was how. Albert Einstein's work was heavily influenced by the laws of motion by Isaac Newton and the laws of electromagnetism by James Maxwell. Maxwell found the speed of light to be fixed regardless of who observed it, but his concept was incompatible with the laws of relative velocity if Newton's laws were deemed universal. So, Einstein imagined standing on a train platform witnessing two lightning bolts from both sides. He would see it at the same time, but logically, a man on a passing train would see the first bolt earlier. This didn't make sense because the measurement of the speed of light made by both men would be different in magnitude since they did not see the bolts simultaneously, therefore contradicting the laws. It was either the speed of light is not constant or there was a mishap in Newton's laws. Einstein then came to the conclusion that time must slow down for the man on the train in order to compensate for the speed of light to be fixed. Einstein called the concept time dilation. As time always moved forward, it contracted and stretched depending on the velocity. In order to calculate the time difference between the two reference frames, Einstein came up with a formula to calculate that because time depends on the velocity of one reference frame relative to another. Delta t was the observer time, delta t naught was the proper time, v was the velocity, and c was the speed of light. At the same time, due to time's flexibility, it had its own dimension called space-time. Einstein suggested that the sun curved the planets around itself, resulting in the planets falling towards the sun, just like when a ball bounces off a trampoline, causing there to be a dip in the middle, and when smaller balls are placed in the trampoline, they will roll toward the ball in the middle. Einstein also applied this concept to Earth's gravity, in which gravity is more intense as you move towards the Earth's center. This was just like how the smaller balls accelerate toward the center of the larger ball that was first originally bounced, or just like when something falls to the ground and its acceleration is faster when it's closer to the ground than when it is higher. With a modern example, the GPS connection that underlies Google Maps is also relying on our understanding of relativity and the time dilation the satellite is going. In essence, time dilation is everywhere, from biological processes to our smartphones. We can thank Einstein for allowing us to stalk our friends on Snapchat.